Hello everyone, in this video I will show you how to train a machine learning model to build a web app that classifies image as picture or not picture. This is my project interface. If I select a image and then classify image, it is showing that this is not the image of picture. If I select a image of picture, then classify image, then it is showing that it is a picture of picture. Here I have installed Torch Vision, Scikit-learn, NumPy and Pillow. I have also installed OS that is used for interacting with files and directories, NumPy for numerical array, plt.image to open images, tqdm gives us processes, bars for loops. Decision tree classifier is our base model. Resample is for creating bootstrap samples for bragging. Accuracy score measures our model's performance. Torch and Torch visions handle deep learning and pre-trained models. Random for random sampling, matplotlib for visualize image, and prevents unnecessary warning. We use filter warning ignored. Here is a function. This function displays sample image from a given category. Root directory points to our dataset folder. Category part combines root and category folder like pizza or not pizza. Random.samples picks a few random images. We load these images using image.open and convert them to RGB. Then we plot them using matplotlib with plot axis off to hide axis. This helps us quickly visualize what pizza and not pizza images look like that. Here we can see the which picture in our training dataset is pizza or not pizza. In this code, we check if a CPU is available using torch.device CUDA. This speeds up computations. Then we define image transformations, like resize all images to 224 into 224 pixels, which is standard for pre-trained model like ResNet. Convert images to tensors so PyTorch can process them. Here we use a pre-trained ResNet 18 model as a feature extractor is equal to true loads with trained on ImageNet. This line removes the final classification layer because we only need features, not the ImageNet levels. We remove the model to CPU if available. .eval sets the model to evaluation mode with disable staining behaviors like dropout. This is our data directory path. We can this is our data set. And this is our two classes, not picture and picture. Features and labels are two empty list. This loop reads all the images and extract feature. Enumerate classes gives a label index 0 for not picture, 1 for picture. Each image is opened, transformed, and sent to the device. Torch.no Brand ensures no gradients are computed, that saving memory. Model images extracts feature, dot flatten, converts features to a 1D array. Features stores image features, labels stores class levels. Finally, we convert them into NumPy array X and Y for training classical ML models. Here I have defined features as X and labels as Y, and we can see the shape. Feature shape is 1966 rows and 512 column, and the labels shape is 1966 and one column. Here back models is a blank list. Here we will append our decision tree models. Now we train our backing ensemble. Here n estimators is equal to 10 means. We train 10 decision tree. Resample creates a bootstrapped dataset for each tree. Each decision tree classifier is trained on a different sample. Finally, all tree are trained and stored in back models. Here we can see that our 10 model are trained. Now, this function predicts using the ensemble. Each model predicts independently. We stack all predictions into an array. Here, this line implements majority voting to get the final level. This gives a single reverse prediction for each sample. We predict on the full dataset and calculate accuracy. In this example, our ensemble achieved over 99% accuracy, which is excellent. Here we install job lib and import job lib. Finally, we saved our trained ensemble using job lib.dump, so we can load it later without retaining. This is useful for deploying models or making predictions on new images. To predict a single image, open and transform the image. Extract feature using RESTnet 18. Reshape features for the decision tree. Use a bagging prediction to get the final level. Print the result either a pizza or not pizza. Here we can see that this is our input image and this is our prediction that is correct. This is also another input image and this is not pizza. Our model predict this is not pizza. Here is the another input image. We can see that this is not a pizza and our model train this is not pizza. Here we have installed request below so that we can use URL. I have downloaded a image from online and put it in a online hosting site and then used the link for prediction as a input image. Here we perform some code and my model showing that our input image is pizza, and here we can see our images and predictions. This is pizza, that is correct. I have downloaded another picture and then give the input, give our model as an input, and then our model is showing that this is not a image of pizza and that is correct. And that's it, we have successfully built a backing ensemble to classify picture images with pre-trained deep features. We visualized image, extract deep features, trained an ensemble of decision tree and predicted single images. If you enjoyed this tutorial, make sure to like, subscribe, and hit the bell for more machine learning projects. Thanks for watching.